Hi, this is Specials Getford again for my 6th video on my portions video series. This video I just want to talk about simplifying fractions. So the goal of simplifying a fraction is using smaller numbers to represent the fraction without changing the value of it. So if I want to simplify a fraction, I'm going to use some smaller numbers. It's going to look different, but it's going to still retain the same value. Much like how 2/4 is the same thing as a half. You can test this by putting this in the calculator, go 2 divided by 4, and then if your calculator has an extra line, you can go 1 divided by 2, and you'll get the same decimal, which is 0.5. So when you're doing the practice problems for this, maybe get a calculator out. Don't use it for simplifying the fraction, but use it to check your work. I will post solutions to the practice problems soon enough. But in the meantime, always use a calculator when you're doing this because you want to make sure you don't change the value of it. So let's look at a first example here. I want to simplify 3/9. Now, why do I need to simplify it? Because I know that this is not in its lowest terms, meaning that there is a factor of 3 that goes into 3 and 9. Here's a way to kind of visualize it so we can develop some intuition here. If I were to cut a whole up into thirds, 1/3 plus 1/3 plus 1/3, that sums up to a whole. I cut this piece into ninths. That means there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of equal size. Well, if I were to shade in, let's see, 3/9. Let's see what that looks like. So I have that ninth, maybe that ninth, and that ninth. Well, let's try and shade in something similar, a similar shape and size on this side. Let's see, if I were to shade in one of these thirds, it looks like I have about the same area on both of them. And I do. Now, why is that? How did I know to convert ninths into thirds? Well, I found the greatest common factor between 3 and 9, and it happens to be 3. It's not always going to be one of the numbers. Sometimes you may have to find another factor of both of those numbers that is not either of those numbers, and I'll show you some examples of that. But here's how I can reduce it, and here's the simple method for reducing 3/9. I know that 3 goes into both 3 and 9. So I'm going to take 3, I'm going to divide that by 3. And what do I get when I go 3 divided by 3? I get 1. Now I'm going to go 9 divided by that same number divided by 3. What's 9 divided by 3? It's going to be 3. So this is a way we can know that 3/9 is equal to 1/3. If you have a calculator out, you can go 3 divided by 9, and you'll get some sort of repeating decimal that will look like this, 0.333, but that just repeats. And the same thing will happen if you put in 1 divided by 3. You'll get that same decimal. All right. Could I have used another factor besides that? Not necessarily, but if I had something like 2/6. Let's say I want to simplify that fraction. Maybe while I'm erasing, you can take your time so you can simplify that yourself. Okay, what does 2/6 look like? If I were to, let's say I were to visualize 2/6. Okay, I'm going to maybe draw that circle right here. All right, so I want to split this up into 6. So I might just do thirds and cut them up into halves. And that looks like more like sixths. How do I know that? Because I have 1, 2, 3, 4, 5, 6 equal pieces. Each piece is the value of 1/6 of my whole. Okay. So I want to shade in something over here that has the same about shape. Let's see. You know what I'm noticing though? 2, 6. If I were to count off 1, 2, it looks like it has about the same size, same portion as 1/3 again. So does that equal 1/3? Well, let's see. How do I get 2 to 1 by using some sort of scale factor? Well, I can divide that by 2. So 2 divided by 2 would equal 1. So if I divide the top part by a number, I have to do the same to the bottom number to create an equal fraction. So 6, I have to go 6 divided by 2. Does 6 divided by 2 equal 3? Yeah. So that means 2/6 and 1/3 they're also equal portions, equal fractions. So that means 1/3, it could be written as 2/6. It could also be written as 3/9. I wonder, could it be written as 4/12? That's just me adding on another 3 on the bottom and another 1 on top. Well, let's see. In order for that to be true, there has to be a scale factor I can multiply 1/3 by to get 4/12. Let's see if I can do that. Let's see, 1 times what number is going to be 4? So in previous problem examples, we were scaling it down. What we're going to be doing is called scaling it up. So 1 times a number is going to be 4 because 4 is bigger than 1. Well, 1 times 4 would be 4. That means I'm going to take 3, and I have to multiply that by 4 as well. Are those two equal? Well, yeah, if I were to put 1/3 into a calculator, I would get that 0.3 repeating decimal. If I were to put 4 divided by 12 into a calculator, I would get that same 0.3 repeating decimal. So why does the scale factor method work? Let's see. If I were to take any other fraction like 4/5, and let's say I multiplied that by 1. Kind of ridiculous, I know. But I should get back my same fraction, 4/5. Multiplying by 1 never changes the value of something. Because you're basically asking, what's one group of something I'm counting? Well, one group of that is going to be whatever you're counting. Same thing if I were to go 12 times 1. I would get 12. If I were to go 1,003,004 times 1, I'm going to get back 1,003,004. Because I'm just saying, what's one group of that? I'd much rather do that math than say, what is 1,003,004 groups of 1? Sure, that's why you can multiply in any order you want and get the same answer. So if multiplying by 1 never changes the value of something, then multiplying it by a fraction that's equal to 1 shouldn't change the value of something either. So what's a fraction equal to 1? Well, let's experiment a little bit. 4 divided by 5. I want to multiply that by some fraction that's equal to 1. Well, we know that anything divided by itself is going to be equal to 1. So let's take our other example where we multiplied by 4. So if I have 4 on top and 4 on the bottom here, that means that 4 divided by 4 is 1, and I don't change the value of it. It's going to be 4/5. But Mr. Jeffrey, in other videos, you said to multiply straight across. Well, okay, let's do that. What is 4 divided by, what's 4 times 4? 16. What's 5 times 4? It's 20. 16 is going to be 4/5 of 20. How do we know that? Well, 4/5, and you can check me on the calculator here, 4/5 is going to equal 0.8. 16/20 is going to equal 0.8. So if you want to check on a calculator, that's fine. If you want to use our previous knowledge about how to convert fractions into decimals, that's fine as well. in fact, in the next video, I'm going to be explaining a lot more on how to convert fractions into decimals. That'll be a big part of the math that you'll need to know for the ASVAB. So by changing 4/5 into 16/20, I didn't change the value of it. So if I were given the fraction 16/20 and we're expected to simplify to 4/5, I know I'm still not going to change the value of that either. Same thing goes with dividing. If I were to, this is me scaling it up. If I were to scale it down and say, so if I'm going from 16/20, so if I'm going to scale this down. I know the biggest factor between 20 and 16 that they have in common is 4. So I'm going to go 16 divided by 4 and 20 divided by 4. What's 16 divided by 4? It's 4. What's 20 divided by 4? It's 5. This is the way that we can go between bigger fractions and smaller fractions, or vice versa. Okay. So hopefully we know enough about our divisibility rules from the last video to maybe help us simplify some bigger fractions. Let's say we took the number 640 divided by 416. Let's see. So I want to know what's the number that divides this number and that number evenly. Now here's a little strategy I like to do when I simplify fractions. If I notice the top and bottom are both even, I like to cut the top and bottom by half. It's an easy calculation to do, and sometimes from there I can maybe see more factors that I can take out of both of these numbers here. So let's start with that. Let's take 640 and cut it in half. So I also want to go over like a little strategy I like to use when cutting a number in half. I said I can treat 640. If I'm going to cut that in half, I'm going to take that 600 and add 40. That's the same thing, same value as 640. I can take 600, cut it in half, and get 300. I can take 40, cut it in half, and get 20. So half of 640 is 320. So that's 320 on top. How about the bottom? 416. Okay, well I'm going to treat 416 like 400 and 16. So half of 400 is 200. Half of 16 is 8. So half of 416 is going to be 208. If you can cut things in half relatively easy, you don't have to use a strategy. This is a strategy for people who, or I guess if you come across a number that it is particularly difficult to cut in half, and we're actually going to see that was 300 because 3 is not an even number. So this strategy will help us, if we need the help, to cut numbers like that in half. I'm going to continue this problem on this side of the board. So 320 over 208. Okay, so how do I cut 320 in half? I can go, let's see, 300 plus 20. And you know what I might do? Let's say I don't have a really good number sense. I don't know that half of 300 is 150 yet. If I need to, I can split that up into 200 and 100. Okay. What's half of 200? Well, it's 100. Half of 100 is going to be 50. Half of 20 is going to be 10. Add that all together, I get 160. Okay, so I have 160 on top. The good thing about the ASVAB is that you can use as much scratch paper as you want. I think I used probably five pages of scratch paper just to kind of confirm that I had the right answer on that. It worked out for me. It might work out for you too. No shame in using a lot of scratch paper. How many people do you think go into that test and they think they're going to do really great and they don't use any scratch paper and they just guess thinking they're going to just fly through it. A lot of them probably think that, but not everyone gets a great score. So if you need to, there's no shame in brute forcing a problem like this. All right, so let's try and cut 208 in half. If you can already see that half of 200 is 100, half of 8 is 4, that's great. If I'm going to use my strategy here, I'm going to say, okay, half of 200, yeah, is 100, half of 8 is 4. Okay, yeah, half of that is 104. I still have even numbers on top and bottom here, so I can keep cutting them in half. Now, you can use some other strategies too with this. If I want to find half of 160, I know that if I were to find half of 16, I would get 8, if you already know your halves like that. So that means half of 160 has to be 80. How do we know that? Well, 160 is a 16 times 10. Okay, and so if I were to go half of one of those factors, I can just go, okay, 8 times 10. So half of 160 is going to be 80. Half of 104. How do I figure that out? Well, it's half of 100. What's half of 4? Half of 100 is 50. Half of 4 is 2. So hopefully we got 52 on that. Oh, look, I still got an even number on top. I guess I got to do it, however many more times. This is getting old. Sure. Go ahead and fast forward. We're almost done now. I have like 2 more steps on here. So half of 80, I know that half of 8 is 4. So half of 80 must be 40. Once you get to these kind of smaller numbers, or numbers that just what they would be if you scaled it down to just the tens or the ones, that you could find halves of pretty big numbers. If I were to ask you what's half of 80 million, well, it'd be 40 million. Hopefully we could go right to that answer. All right, so half of 52. So I got to find half of 50 and half of 2. Hopefully we know what half of 2 is. Okay, so half of 50. Maybe what I could do here is I could go half of 40 and then half of 10. Half of 40 is 20. Half of 10 is 5. So 20 plus 5 plus 1, that's 26. All right. So half of 40. I know that half of 4 is 2. So that's going to be 20. Half of 26. Let's see, I could go half of 20. Half of 6. Half of 20 is 10. Half of 6 is 3. So 13. All right, so 13 is a prime number. We could not possibly simplify this any further. If you're simplifying a fraction and you come across that, when you realize that either the top or the bottom number is a prime, meaning it has no other factors besides 1 and itself, you can stop right there. You're done simplifying. So how can I check to see that this is the same value that I simplified correctly? Well, if I put 20 divided by 13 in the calculator, I should get the same number as if I put in 640 divided by 416 in the calculator. Let's see, and if I were to have to do long division, I'd much rather do long division of 20 divided by 13 than 640 divided by 416. I'd much rather do that. I'm going to get to the answer a lot quicker. But hopefully, if you practice the cutting number in half strategy enough, that it will be more intuitive. You should be able, in the field, you should be able to intuitively know what half of a number would be, without doing a whole lot of work there. So you can take it apart, visually in your mind, each digit, cut it in half. If you realize you come across any odd numbers, take it apart, kind of like we did with that 50. 40 and 10. Okay, so 25. All right. Let's see, I want to do a couple more examples. I think I'm kind of going over time here, so let's use one that uses our divisibility rules. So if I had something like 306, and I have let's say 90 on the bottom. Here's one thing I noticed. I noticed that if I'm using my divisibility rules from last video, I know that 3 plus 6 equals 9. Oh, and 9 plus 0, that's 9. So I know that 9 is a factor of both of these. I know how to go 90 divided by 9. I might struggle a little bit with 306 divided by 9. But I know that if 9 goes into it, 3 definitely goes into it. I can divide 306 by 3 a lot easier than I can simplify 90 divided by 3. Here's how we can do it. So 306 divided by 3, we're dividing by 3 this time. I can use a very similar strategy to cutting the numbers in half. I can treat that like 300. I can treat that like 6. What's a third of 300? Or 300 divided by 3? Well, it's got to be 100. What's 6 divided by 3? It's 2. So 1/3, if I were to divide the top and bottom by 3, I would get 102. And hopefully we can kind of see that if we were to multiply 102 times 3, we would get back 306. All right, so now I have to go 90 divided by 3. What is 90 divided by 3? Well, if you know that 9 divided by 3 equals 3, if we know that intuitively, then 90 divided by 3 would just be 3 with a 0 on it, so 30. Okay, I am noticing that I can divide both the top and the bottom by 3 again. And we already knew that going in here because we knew that 9 would divide it. So that means 2 factors of 3 definitely would go into it because 3 times 3 is 9. So let's do that again. So 102 divided by 3. What's an easy way I could do it? Could I go 100 and then 2? Here's the thing. Those are not multiples of 3. I do know that 102 is divisible by 3 because 1 plus 2 is 3 if I add the digits together. So here's what I want to do. 102, I know that 90 plus 12 will get me 102. If you take one number that's divisible by 3, you can add it, the next number that you'll have to add will also have to be divisible by 3. If I were to do, let's say another number, I used a different number. So if I used 60, what's 60 plus something is 102. I know 60 plus 42 is also 102. So if you pick something that you know is divisible by 3, and you know that this number is divisible by 3, you know the other one's going to be divisible by 3 as well. I want to stick with 90 and 12 real quick because I already did a third of 90, and I don't want to have to repeat work, especially when I'm in the middle of a test. So I'm going to just immediately say, okay, 1/3 of 90 is 30. 1/3 of 12, or 12 divided by 3 is 4. So I'm going to have 34 as 1/3 of 102. Okay, now last part here. 30 divided by 3. So I also have to divide 30 by 3. Hopefully, if you know that 3 divided by 3 equals 1, that means 30 divided by 3 is going to be 10. It's just going to be a 1 with a 0 on it. Okay, last step here. It looks like both the top and bottom are even, so I can go ahead and just cut the top and bottom by half again. That'll be our last step because I know that 10 divided by 2 is going to be 5. So I'll just go ahead and do that. So now I have to go 34 divided by 2. Okay. So I can go half of 30, then half of 4. Okay. Let's say I don't have good number sense. I'm going to go half of 20 and then half of 10. So half of 20 is 10. Half of 10 is 5. Oops. That's supposed to be 10. And then half of 4 is 2. So 10 plus 5 plus 2 is 17. And hopefully we see that if we doubled 17, we get back 34. I have 2 prime numbers in my fraction, so I'm done. I was done after the first prime number. Well, you want to hold off on that sometimes. Sometimes if I were to have like a 25, then I wouldn't be done yet. But I do have 2 prime numbers in my fraction. I know I'm done. This is the same value as 306 divided by 90, if you put those in the calculator. Okay. I feel like we should do a couple more. Now, I think that's good. If I'll put some practice problems and solutions in the bottom in the description below. And maybe just one more quick rule. If you ever see anything like this for simplifying fractions, I'd be remiss if I did not go over one example like this. If you see something like 800 divided by 50, or I'll do something else, like I'll do like 70, just so I know I only have to do it once. So 800 over 70. I want to simplify that fraction. Every time you have zeros on top and bottom, the top is basically 80 times 10. If I were to multiply that out, I get 800. 70 is basically 7 times 10. What's 10 divided by 10? Well, it's 1. So we can just cross those out, and we're just going to have 80 over 7. So if you had something like 3 million over 9 million, here's what I urge you to do. Look at all the zeros here, cancel them out one at a time there. I know you can go 0 for 0 on there, and my ratio is still going to be 3 over 9. Maybe then from there, I can just say, okay, I know from previous examples that if I go 3 divided by 3, I get 1. 9 divided by 3, I get 3. So whenever you see zeros on a fraction like that, you can just cancel them out, but only if you cancel the same amount of zeros on the top and bottom. If, however, you had an example like 1200 over 180. I have 1 0 on the bottom, so I can cancel out 1 0 there and 1 0 there, but that's all the zeros I can cancel out at the moment. Don't cancel any more zeros than the top and bottom. You always cancel out the same amount of zeros on the top and bottom. I had 6 zeros that I could cancel out on the top and bottom here. I only had 1 0 I could cancel out on the top and bottom over here. And then from here, obviously, I can just I can divide. Let's see what I can divide this by. Let's try dividing by 6 real quick. I know that the top and bottom are even numbers, and I know based on my divisibility rule by 3 that they're both divisible by 3. So if they're divisible by 2 and 3, that means they are both divisible by 6. So I want to take 120 and divide it by 6. Let's see. I know that 12 divided by 6 equals 2. So, okay. So if I have 120 divided by 6, that's going to be 2 with the 0 on it. Okay, that means I got to go 18 divided by 6. Now for numbers that are this low, this might just be something we do have to practice. I know that 6 plus 6 plus 6 equals 18. So 1, 2, 3 groups of 16. 18 divided by 6 is going to be 3. All right, so check out those practice problems below in the description. And yeah, let me know if you need any help with them. I am always there. My schedule is open. And I'll see you in the next video.